right? So I arrived just as the big Omicron wave of January 22 had just subsided. And as far as I knew, we were going to get new variants every day. Things could go very wrong. We didn't know. And I spent a lot of time thinking about how are we going to detect them? How are we going to respond to them? So what's your framework for how do we make the world safer from engineered biology? And how do we make the world safer from natural biology that is changing rapidly because of all the changes that we have made through globalization and climate change?
Yeah, so I think the cool thing is it's mostly the same thing. It's mostly the same system you have to set up. And what we try really hard to do when we're thinking about this from first principles is remember that basically this is a technology problem created both by humans inventing bioengineering, but also a natural biotechnology problem. So we have to then take these modern tools of biotechnology we have and say, like, what is the system that needs to be created? And it feels like a big problem until you break it down into like a couple analogies, right? This is not the first time we have had a threat that we've had to build a detection to response system. So today, for nuclear weapons, for example, I don't pretend to know the numbers, but we have massive constellations of satellites and multiple different types of intelligence being collected all around the world. We do the same thing with cyber. We're monitoring the zeros and ones. Every single device at all times is being monitored for threats. And we're able to identify it quickly and then start patching with software. Well, we have to build the same thing for bio. We've started by doing it, really thinking about where are the choke points where you would identify a bio threat. And so we've launched a program in conjunction with both of the last two administrations where we're monitoring airports. Global travel, as you identified, so every time an airplane lands in, not every time, but many times an airplane lands in going now 9 airports in the US and also in places like Doha, in Qatar, in Rwanda, soon to be Botswana. We're taking wastewater off those airplanes and immediately doing DNA sequencing on it to be able to alert if there is something that is dangerous, either a new variant of, say, SARS-CoV-2, or now we're monitoring for 66 pathogens of concern. That's just like what we do in these other areas. We build a surveillance system. And so when we're building these monitoring nodes, radar stations, if you will, what you're doing is really you're turning the environment, non-human, right, all the pathogens of the world, all of the plants and things that can hurt humans, you're turning the environment into a data problem via the DNA sequencer. And if you can start doing that over and over again, then if something bad happens, you're able to trace it back through the network to understand, was it natural? And if it was natural, fine, we need to figure out how to stop it. Or was it something that a bad actor was trying to create to do harm to our society? And then if we are able to figure that out, there's plenty of ways to raise the cost to actors to do that. But you really need this mindset shift around biology. It is not just happening to us. We are very much able to, in a sophisticated way, engage with it.